Today we're looking at notes 10-4, solve radical equations. So the steps for solving a radical equation are as follows. First, you want to get the radical by itself or isolate the radical. Raise both sides to the power of the radical is what's next. And then you simplify and solve or get the variable by itself. Then for all the problems today, you definitely want to check your solution because you may end up with some extraneous solutions now and again. All right, looking at example number 1, we have fifth root of quantity x plus 1 minus 6 equals negative 4. So first, to isolate our radical, we need to get rid of the negative 6 by adding 6 to both sides. So here we get fifth root x plus 1 equals 2. And then we want to raise both sides to the power of the radical. So that's raising to the fifth power, because the fifth power and the fifth root will cancel each other out. So you have x plus 1. And then that equals 32. So you will subtract 1 from each side to solve for x. You get x equals 31. And before you want to box that, you want to check it. And how we're going to do that is we're going to open up our calculator. And if you look in math, which is under alpha, if you scroll down to number 5, you see that little X for an index. That means you can, type in whatever index you want. So on this one, since it's trying to put something in there for us, you need to type over it. So fifth root of x plus 1. X is 31, so 31 plus 1. Scroll out of the radical, minus 6, and it should equal negative 4. So it does, so that means it's not extraneous, it does work. We can go ahead and box it up. All right, let's look at another example. Example 2. Example 2, 4 times the cube root of 2x plus 1 equals 12. Okay, in order to isolate our radical, we need to divide both sides by 4. And then we have cube root 2x plus 1 equals 3. Raise both sides to the third power to get rid of that cube root. So we have 2x plus 1 equals 27. Subtract 1 each side. You get 2x equals 26. Divide by 2 on each side. You get x equals 13. Again, before you box, you want to plug 13 back in for x. Plug it in the calculator, make sure it works. So on this one, just in order to save time, I already did this, and it does work, so we'll box it. Okay, let's look at another example of this type, and then we'll move on to something more difficult. So example 3, 2 fourth root x. So example 3 is 2 fourth root x, and then plus 7 equals 13. Okay, so on this one, to get the radical by itself, you need to subtract 7 from both sides first. So you have 2 fourth root x equals, that would be 6. Okay, and then on this one, you're going to divide by 2 next. Okay, so you get fourth root x equals 3. And then to get rid of the fourth root, you raise both sides to the fourth power. And you get x equals 81. Okay, again, in order to save time, I have already plugged that back in. It does work. It's not extraneous, so you can go ahead and box it. But in class, you'll need to check them on your own. All right, I need to flip over because the next one takes up quite a bit of space. So this is example 4. Okay, example number 4 is parentheses, x minus 3, close our parentheses, raised to the 2/3 power equals 4. So I want to remind you, after dealing with our rational exponents lesson, what this exponent means. That means we've got a cube root because the denominator indicates our root. And the x minus 3, the numerator, represents the power here. So I've got cube root of the quantity x minus 3 squared equals 4. So you want to work outside in on this problem. So what you're going to do first is you're going to get rid of the cube root, raise both sides to the third power. Okay, so that gets rid of the cube root. So we've got x minus 3, still squared, haven't gotten rid of that yet, equals 4 to the third power is 64. Okay, now we need to get rid of this square up here. So to get rid of square, you guessed it, we square root to each side. So here's what we need to think about. This is square root of x minus 3 squared. That means we have 2 x minus 3's. So we've got a group of 2 of these. So this x minus 3 will come out because we're looking for groups of 2 because it's square root. Okay, but since this is an even index and what we're taking out is an odd power, it's x minus 3 to the first, this gets absolute value. Okay, and then square root of 64 is 8. So a lesson you learned way back when, and just thinking about it now, absolute value basically means that whatever's in here, if it's negative, it becomes positive. If it's positive, it stays positive. So how we rewrite this is x minus 3 equals plus or minus 8. So essentially you have to set up two problems. X minus 3 equals 8 and x minus 3 equals negative 8. So here, add 3, you get x equals 11. And on this one, when you add 3, you get x equals negative 5. Okay, before you box either of these, you need to check it by plugging it back into the original equation. So you'd plug in 11 here, and then make sure you raise it to the 2/3 power, should equal 4. Plug in negative 5 here, raise it to the 2/3 power, should equal 4. If either of them doesn't work, then that would be extraneous, you wouldn't box it. On this problem, they both work, because I've checked them, plugged them into the calculator, so I would box them both. Okay, that was a lot of work for one little bitty problem, okay, especially since I didn't have to isolate anything here. There is an easier way. I want to show it to you, and you can decide which method you want to use. So what we have here, same problem, just rewriting it, x minus 3 to the 2/3 power equals 4. What you can do instead of converting this to a radical is, and this will probably make sense to you when you see it, raise both sides to the reciprocal power. Why does raising both sides to the reciprocal power make us be able to solve real quick? Well, when I have a power to a power, I multiply those numbers. 2/3, I'm just going to write this off to the side, 2/3 times 3/2, think about what happens there. I've got 2 times 3, which is 6, and 3 times 2, which is 6. So 6 over 6, which actually equals 1. So this essentially would be x minus 3 to the first, okay, equals, and then you'd have to type this into the calculator or do it in your head. 4 to the 3rd power, and then take the square root of that, okay? Or you could just simply type 4 raised to the alpha y equals 3/2, get your answer of 8. So here's what you have to remember though. If you use this shortcut method, you have to remember, write it out, have to remember to use plus or minus, so here on the 8, because the denominator 2, so the denominator 2 here indicates square root. So you'll have to remember kind of the step that we did over here when you took out that odd power with an even index, you'll have to remember it here. If the denominator is even, you will need a plus or minus here, just like we have here. So it ends up giving you the same answer, so long as you remember that when you have an even denominator, you'll have to have plus or minus, okay? So essentially, if your numerator in the beginning starts off as even, then your denominator will start off or end up even here. So then you have to worry about plus or minus. So I'm not going to resolve that problem because you get the same answer. Okay, so that nude method is especially easier when, let's look at it. I have a different problem like this. 3 times x plus 2 raised to the 3/4 plus 1 equals 25. Okay, before I begin on this one, even if I do want to use the long method of converting it, I've got to get the radical by itself. So I've got a minus 1, minus 1. So here I've got 3x plus 2 raised to the 3/4 equals 24. And then I've got to divide by 3, divide by 3. So x plus 2 raised to the 3/4 equals 8. Okay, here I could do the long way, convert this to a radical, or I could just raise both sides to the reciprocal power. That would be 4/3. Raise both sides to the 4/3. So here, 3/4 and 4/3, that's going to reduce to 1. So I can just write x plus 2 equals, and then I would type that in the calculator, and you should get 16. Okay, here's the thinking on this one. This one started off with an even number in the numerator, and so when we took the reciprocal power, it ended up giving us a square root. On this one, it started off with an odd number in the numerator, so when we raised to the reciprocal power, it was just 4/3. And so that essentially means I'm taking the cube root, and I don't have to worry about absolute value when I take cube root. So on this one, you just leave it. So I think this method is much faster. Okay, in order to clean up, you just subtract 2 from each side. So x equals 14. You would have to plug that back into the original problem to check it, see if it works out. And I already did that for you. It does. We're good to go. Let's do one more example. Try and make it under the 15-minute mark. So example 6, negative quantity x plus 6 raised to the 3/2 power plus 4 equals negative 23. So on this one, subtract 4, I get negative x plus 6 raised to the 3/2 equals, since that canceled, negative 27. I've got to get rid of that negative out in front, so divide both sides by negative 1. That would make this positive x plus 6 raised to the 3/2 equals, that would turn to a positive 27. Raising both sides to the reciprocal power, that would be raising to the 2/3 power. So again, on this one, that goes away to 1, so I get x plus 6 equals, think about it, do I need absolute value bars? No, because the denominator indicates what root I'm taking, and that's an odd number. So cube root means I don't have to worry about absolute value, so this would just be 9. Plug it in the calculator, get 9. Subtract 6, you get x equals 3. You would want to check this by plugging it into the original, making sure it pops out negative 23. It does. I've checked it. You can box it.